In Episode 3, titled The 4 Exam Priorities, Security, Availability, Performance, and Cost Trade-offs, we focus on 4 priorities that quietly guide most network and cloud decisions every day, whether you realize it or not. The exam often looks like it is asking about tools and architectures, but many questions are really testing whether you can recognize which priority is in charge in the scenario. When you know the priority, you can evaluate the answer options with a steady hand instead of guessing based on what sounds most advanced. These 4 priorities also show up in real operations, because every environment has limits and every decision is a trade, even when people wish it were not. The goal here is to make your thinking explicit so you can rank trade-offs quickly and pick the best answer with confidence. Before we continue, a quick note: this audio course is a companion to the CloudNetX books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. Security is the priority that asks you to reduce trust, narrow access, and log meaningful actions, because control without visibility is just hope with paperwork. Reducing trust means you avoid assuming that internal traffic is safe, that a known network is trustworthy, or that a familiar identity is always legitimate. Narrowing access means least privilege in practice, which is not just fewer permissions, but smaller blast radius when something goes wrong. Logging meaningful actions means you capture events that reflect real risk, such as changes to access, changes to configuration, and access to sensitive data, rather than drowning in noise that cannot be reviewed. In scenario terms, security-driven answers tend to emphasize strong authentication, tight authorization, segmentation boundaries, and auditability that helps incident response and compliance. When the exam leans into security, it is usually telling you that trust boundaries must be tightened and that access must be provably controlled. Availability is the priority that pushes you to remove single failures and plan safe failover paths, because downtime is rarely a single moment and more often a chain reaction. Removing single failures means you identify components that everything depends on and you redesign so their loss does not take down the service. Safe failover paths mean the system can shift to an alternative without human heroics, without confusing state, and without violating security controls in the rush to restore service. Availability is not only about duplication. It is about clarity in what happens during partial failure, such as a zone outage, a link issue, or a degraded service. In scenario questions, availability-focused answers often include redundant paths, health checks, graceful degradation, and clear recovery behavior that keeps critical functions alive. When the exam signals that outages are unacceptable, you should treat any single point of failure as an immediate disqualifier. Performance is the priority that centers on managing latency, loss, and jitter for key flows, because user experience is often shaped by the worst moments rather than the average. Latency is delay, and it matters in interactive systems, authentication, transactional databases, and any workload where many small calls stack into noticeable lag. Loss is dropped traffic, and even modest loss can crush throughput and reliability for certain protocols, especially over long-distance paths. Jitter is variability, and it harms voice, video, and real-time control because inconsistency is harder to buffer than steady delay. Performance is not about speed for its own sake. It is about protecting the flows that matter most so that services remain usable when the network is stressed. In scenario terms, performance-driven answers often reduce hops, place services closer to users, avoid unnecessary inspection in hot paths, and prioritize traffic that needs stability. Cost is the priority that asks you to right-size, avoid orphaned resources, and control surprises month by month, because cost is often the constraint that determines whether a solution survives long enough to mature. Right-sizing means resources match actual load patterns rather than peak fears, and it usually involves choosing scalable designs that do not require permanent over-provisioning. Avoiding orphaned resources means you do not leave behind unused instances, abandoned storage, or forgotten network constructs that keep billing silently. Controlling surprises month by month means you design with predictability, monitor usage, and prefer architectures where growth in consumption is visible and explainable. In scenario logic, cost-focused answers often avoid unnecessary redundancy, limit premium features that are not required, and emphasize governance that prevents drift. When the exam highlights budgets, fluctuating demand, or cost overruns, it is telling you that the best answer is the one that meets requirements without silently multiplying spend. The trick is that these priorities are not equal in every scenario, so you need to know when security takes the lead. Prioritize security when data is sensitive or access spans many identities, because more identities and more exposure points increase risk even if each individual access seems reasonable. Sensitive data can include customer records, regulated information, payment details, or proprietary intellectual property. And scenarios often hint at sensitivity through compliance language, audit concerns, or past incidents. Many identities can mean a large workforce, contractors, partners, customers, or distributed service accounts, and each category adds complexity to authentication and authorization. When the scenario implies broad access, security is often the best first move because compromised credentials become more likely and the blast radius is larger. In those cases, answers that reduce implicit trust and strengthen identity controls tend to be favored even if they add some operational overhead. Availability should take the lead when downtime harms safety, revenue, or critical operations, because the consequence of failure defines the acceptable design. Safety can include anything that impacts physical systems, healthcare delivery, emergency response, or environments where an outage creates real-world risk. Revenue impact is often implied by customer-facing services, time-sensitive transactions, and service-level agreements where penalties and churn follow outages quickly. Critical operations can include internal systems that keep an organization running, such as logistics, manufacturing coordination, or core identity services that everything else depends on. In these scenarios, the exam expects you to treat resilience as a first-class requirement, not a nice-to-have. When availability is the priority, answers that rely on a single gateway, a single region, or a single critical dependency usually fail the test. Performance becomes the priority when users complain, media streams, or transactions time out, because poor performance is often experienced as failure even when the system is technically up. User complaints are a strong signal that the problem is visible at the edge of the system, which is where latency, congestion, and path inefficiency show up. Media streams and real-time collaboration depend on stable delivery, and jitter or loss can degrade quality rapidly even if bandwidth seems sufficient. Transaction timeouts often indicate that latency budgets are being exceeded or that downstream systems are slow, and network choices can either amplify or reduce that pain. When performance is signaled, the exam usually wants you to choose options that shorten paths, reduce unnecessary processing, and protect key flows from congestion. In those cases, the best answer is often the one that improves the experience for the critical path, rather than optimizing a less important metric. Cost should become the priority when usage fluctuates, and budget discipline enables continuity, because variability can quietly turn a reasonable design into a financial crisis. Fluctuating usage is common in seasonal businesses, event-driven demand, development and testing environments, and workloads with unpredictable spikes. When demand is variable, the most expensive designs are often the ones that assume peak load permanently and keep resources running just in case. Budget discipline enables continuity, because organizations that cannot predict or control spend often respond by cutting corners later, which increases risk and reduces maturity. In cost-driven scenarios, the exam tends to reward right-sizing, measured redundancy, and controls that prevent waste from accumulating. The underlying lesson is that a solution that cannot be paid for next quarter is not a reliable solution, even if it looks elegant today. Conflicts are where candidates stumble, so resolve them by ranking priorities, then choosing the simplest, adequate design that satisfies the top priorities without creating unacceptable harm to the others. Ranking priorities means you identify which one is non-negotiable in the scenario, which one is second, and which ones are flexible. Simplicity matters because complexity adds operational risk, and operational risk can undermine all 4 priorities at once through misconfiguration, delayed response, and brittle dependencies. Adequate design does not mean minimal effort. It means meeting the required outcomes with a design that can be understood, maintained, and verified. If security and availability are top priorities, a slightly more expensive but resilient design might be correct, while a cheap single point of failure design is not. If cost and performance are top priorities, an over-engineered, inspection-heavy path might be wrong, even if it is more secure in theory, because it violates the ranked needs. Watch for traps where cheap choices create expensive incidents later, because the exam loves to test whether you understand total cost rather than only monthly billing. A design that saves money by skipping segmentation, weakens identity gates, or reduces logging might look attractive under a cost lens, but it can turn one compromised credential into an environment-wide incident. Incidents have costs that show up as downtime, recovery labor, reputation damage, and sometimes regulatory consequences, and those costs can dwarf the savings from cutting the wrong corners. The trap is not that cost awareness is wrong. It is that false economy is common when controls are treated as optional. In scenario questions, you should be suspicious of answers that are cheaper because they remove controls that protect sensitive paths or because they centralize critical dependencies without redundancy. The best answer usually respects cost while still preserving the minimum controls needed to prevent catastrophic outcomes. To get fast at this, practice quick trade-offs using one scenario and 4 different stakeholder views, because stakeholders implicitly rank priorities even when they do not use the same words. A security leader will often prioritize reducing trust and improving auditability, especially when access is broad and the environment is dynamic. An operations leader will often prioritize availability and recoverability because they are the ones who get the call when a dependency fails at night. A product or customer leader will often prioritize performance and user experience because adoption and satisfaction depend on responsiveness and reliability. A finance leader will often prioritize cost predictability and waste reduction because continuity depends on sustainable spending. When you can imagine how each stakeholder frames the problem, you get better at spotting which priority the exam is signaling, and you become less likely to be tricked by an answer that optimizes the wrong thing. For a mini-review, say each priority clearly, then name its first control, because each priority has an initial move that usually shows up in correct answers. For security, the first control is an identity gate that enforces authentication and authorization in a way that narrows trust rather than expanding it. For availability, the first control is removing a single point of failure at the boundary that everything depends on, so that recovery does not require a miracle. For performance, the first control is protecting the critical path by reducing latency contributors and avoiding unnecessary hops or processing in key flows. For cost, the first control is right-sizing and preventing waste, so that spending matches actual usage and surprises are minimized. When you can name the first control quickly, you can often predict which answer choices are aligned with the priority before you. Overthink the details. In the conclusion of Episode 3, titled The 4 Exam Priorities, Security, Availability, Performance, and Cost Trade-offs, the goal is to make your decision process explicit so you can apply it in both exam questions and real architecture work. Security is about reducing trust, narrowing access, and logging meaningful actions, while availability is about removing single failures and planning safe failover paths. Performance is about managing latency, loss, and jitter for the flows that matter, and cost is about right-sizing, avoiding orphaned resources, and controlling surprises month by month. When a scenario presents conflicting pressures, you rank the priorities and choose the simplest, adequate design that satisfies the top priorities without creating unacceptable risk in the others. Choose one priority and apply it to today's decisions, and you will start seeing trade-offs more clearly instead of treating them as frustrating compromises. That clarity is what the exam rewards, and it is what makes you a steadier engineer when the environment is messy and the stakes are real. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.